Hello, my name is David Malin, and I'm the instructor for Computer Science E1, Understanding Computers and the Internet at Harvard University's Extension School. You're watching one of our videos of the week. For more such videos or information about this course, visit us on the web at computerscience1.org. Enjoy the show.
Hello, I'm Dan Armendariz, a TA for Computer Science E1, and you're watching one of our videos of the week. In today's video, we're going to be talking to you about the Standard of Internet Communication, or Tcp Ip. So you're watching our video of the week, but how is the information from this video being transferred from our computer to your computer, wherever you may be? Well, like I said, we use the Standard of Internet Communication, Tcp Ip. TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. Now, these are two separate standards that are working together to bring you the information from this video of the week. In TCP, this actually breaks apart the video into tiny little packets and transmit these packets to you over the Internet. IP is what's used to be able to find your computer from our computer so that those packets can be transmitted to you. So this actually is somewhat analogous to a shipping company. Let's say you had to move a large volume. Maybe you have to move your house, for example, from here in Cambridge all the way to Los Angeles. You don't ship your entire house all at once. You break it into very small pieces or small packages, and then you ship it to the address in your Los Angeles location. Using this method, it's actually easier for you to ship all of the pieces from your home here in Cambridge to Los Angeles. So first, let's talk a little bit about Internet Protocol, or IP. This is the way that your computer can find ours. Now, just like if you were mailing stuff back to your home in Los Angeles, what you would do is you would write your address on the package and then ship it. Similarly, every computer on the Internet has its own address, or an IP address, so that you can find it online. So let's say that you were going to fas.harvard.edu. Well, you don't necessarily have to do that. Every computer, like I said, has an IP address, so it has a number associated with it. In the case of FAS, our IP address is 140.247.34.98. And if you try to go to this website, just go ahead and try it, you can see that it brings us to the FAS website. So similarly, we can try just going straight to fas.harvard.edu. If we go there, it brings us to the same one. This is because of another standard on the Internet known as the Domain Name System, or DNS. Because of this, we're able to type text, so fas.harvard.edu or google.com, for example, and it translates that into the IP address of your server. Then, using IP, it finds that server based on its address. So let's say you were trying to visit our website in order to watch the videos of the week. You enter in fas.harvard.edu into your web browser, and you hit return. The DNS system translates this into the IP address of our computer. Your computer sends a request to that IP address, which is routed through a number of routers from wherever you may be to our location here in Cambridge, Massachusetts. Similarly, if you're sending a package, let's say from here to Los Angeles again, it doesn't arrive directly in Los Angeles after being shipped to Cambridge. No, what it does is it follows a path. First, it may go to a mail hub here in Cambridge, then it may fly to Phoenix, for example, where it's sorted yet again, and then the package is finally sent to its destination, Los Angeles. So you found our website, and now you're downloading the video of the week. But how is this information being transmitted from our server to your computer? Well, thanks to TCP, or Transmission Control Protocol, it's being broken apart into packets. Now, just like I was talking about before, you don't move your entire house in one very large box. You break it up into smaller pieces, and you label each one, and you ship it over. Similarly, that's what TCP is doing in this case. It breaks apart the information into tiny packets that are about 1,000 bits or 1,500 bits in size. Each packet is labeled with a header. So just like you would label your package with the return address, the ship to address, and perhaps you might label what the contents are, the header of a packet has this information: the sender's IP address, the receiver's IP address, the packet number in the sequence of packets, and the packet size. And then, of course, there is the data that's associated with the packet. This way, when the recipient computer, or in this case yours, receives this data, it can put the packets back together and reconstruct the video of the week. There's a technology called streaming that we can use so that the whole file doesn't have to be downloaded before you can watch it on your machine. If you're watching us over YouTube, for example, this is probably what's happening. Sometimes with the technology called streaming, the entire file doesn't have to be downloaded for you to be able to begin watching it. Well, that's TCP IP in a nutshell. I hope you enjoyed it. Thanks for watching this week's video of the week. I'm Dan Armendariz. See you next time.